In this next unit, we'll be learning about exponential functions. We've already learned about linear functions, so let's look at some real-world examples to see the differences between the two. You know that the equation for a linear function is y equals mx plus b, where m is your slope, or also called your rate of change, and you should be writing all this down. B is your y-intercept, or your starting value. So Julie is trying to win a hot dog contest. Julie is trying to win a hot dog eating contest next month. Right now she can eat 4 hot dogs in one sitting. To train, she's going to eat 2 more hot dogs each day. So she's eating 2 more hot dogs each day. So she's adding 2. That makes it linear. If you're adding or subtracting every time, that's linear. One thing that you'll need to know is that linear goes at a constant rate. Okay, so let's write our function rule. Y equals, her starting value is 4. She originally could eat 4 hot dogs, and she adds 2 more each day, so that's going to be 2x. So the starting value is 4, and the rate of change is 2. All right, let's make a table. So we'll do 0, 1, 2, 3, and that represents days. So in the beginning, when there had been 0 days, how many hot dogs had she consumed? 4, because that is how many she could eat in the beginning. That was her starting value. And remember, the 0 is your starting value. It's your y-intercept, okay? Then she adds 2 every day. So if we add 2, that would put us at 6. If we add 2 more, that puts us at 8. And if we add 2 more, that puts us at 10. Feel free to pause this video at any time and go back and listen to the explanation. All right, so if we wanted to make a graph, our y-intercept is 4. So I'd go up 4 and put a point. And then my slope is 2. So I go up 2 and over 1. And I draw a straight line, okay? Excuse me. All right, exponential has a different formula. Y equals a parentheses 1 plus or minus r. R is your rate to the x power. Notice this one has parentheses in it. It means you're multiplying. All right, exponential multiplies. Also notice that x is in the exponent. That's why it's called exponential. All right, Jack invested $500 at a yearly interest rate of 8%. The majority of the time when you see a percent, that's going to be exponential because a percent is not constant. For example, if I try to take 50% of 100, well, that's 50. But if I take 50% of 200, that's 100. So it's not constant. A percent does not give you a constant amount, okay? All right, so I see a percent, so I'm going to use this formula. Y equals, A is your starting value, which we always know is the y-intercept. So in this case, how much money did he start with? He started with 500. Then you always put a 1, and you have to decide if it's plus or minus. So in this case, he's earning interest. Interest means you're adding money to the account. So we're going to add, and then our rate is 8%. You have to turn this into a decimal. So 8%, you move it 2 times. You always move it 2 times. So it becomes 0.08 to the x. All right, your starting value is 500, and the rate of change is 1.08. It's this number. That's your rate of change, okay? All right, for our table, we'll do 0, 1, 2, 3 again. And for 0, it started at 500. To get these amounts, you're going to need to use your calculator. So go ahead and get your calculator out, pause the video. And you're going to go to your y equals, and you're going to type in the rule we made, 500, 1 plus 0.08. And then you're going to use this key right here to do the exponent. And you're going to put in an X. And then I'm going to go to second window, and I'm going to tell it to start at 0. All right, so 0 is 500. Then at 1, it's 540. At 2, it's 583.2. And then at 3, it's 629.86. All right, the graph, we're just going to do something real basic. We know the y-intercept is 500. And exponential, this is new, exponential makes a curve. So it looks like this. It makes a curve, it goes through this point, and it curves up. Okay? All right, example 2, eagles are an endangered species. There are only 100 left in the wild, and a half disappear each year due to poaching. This is also exponential because half are disappearing. So we're going to be multiplying by a half. We're not adding a half. So you're not adding a half eagle. You're not subtracting a half eagle. You're multiplying by a half. Whenever you're multiplying, that's exponential. So y equals, what is your starting value? 100. And then you're multiplying by a half. So this 1 plus or minus, that you use whenever you have a percent. You use this one. Whenever you know what you're already multiplying by, you just put it in the parentheses, and then you put x up high. All right, the starting value is 100, and the rate of change is a half. All right, let's do 0, 1, 2, 3. So when 0 years had passed, there were 100, and then half disappear. What's half of 100? 50, then 25, and then 12.5, which I know you can't have half an eagle, so you could say 13 if you wanted. All right, this graph is gonna have a y-intercept of 100. This one is going down. The number of eagles is going down, so this curve goes down. Up here, your money was increasing, so the curve goes up. Okay? All right, we're gonna be working on this for the next week. So you'll get lots of practice with this, but this is just your introduction.